Welcome everyone. Until now, we learned limit properties to evaluate a limit, but sometimes we cannot use our properties. For example, limit of 1 over x squared as x approaches to 0. If you try to use your limit property and try to plug the 0 in, you get 1 divided by 0, which is not defined from what you learned from high school, right? In high school, you learned you cannot divide any number with 0. Therefore, this cannot be your answer. In limits, if we have problems like this, for example, 0 over 0, infinity over infinity, infinity minus infinity, if we get these forms from a limit, we call those indeterminate forms. Be careful here. Just because there's an indeterminate form, we cannot say we don't have a limit. We still have a couple of strategies for indeterminate forms by using algebra. In this video, we will learn those strategies. For example, our first strategy is factorize numerator and denominator, then cancel the terms. Of course, we have a famous equation, right? A squared minus b squared is a minus b multiplied with a plus b from high school again. Limit of x squared minus 25 over x minus 5 as x approaches to 5. First, you will try to plug in, of course, to see if you can use your limit properties. 25 minus 25 over 5 minus 5, 0 over 0. You cannot use the limit property because we are working with an indeterminate form. Then we have to try to use the strategies. Limit of, instead of x squared minus 25, I can write x minus 5 multiplied with x plus 5 over x minus 5 as x approaches to 5. I can cancel these two terms. Limit of x plus 5 as x approaches to 5. Plug the 5 now. 5 plus 5 is 10. Limit of x squared plus 2x over x as x approaches to 0. If you try to plug it in, 0 plus 0 over 0, 0 over 0, indeterminate form again. What else I can do? My denominator is 0. If my denominator was not 0, I could have saved myself. I want to do something to my numerator that x's will cancel each other. If I take this part under x parentheses, x plus 2, limit of x multiplied with x plus 2 over x as x approaches to 0. Now I can cancel the x's out, plug the 0 in, my answer is 2. Limit of x squared plus 2x plus 1 over x plus 1 as x approaches to 1. First, I will try to plug in again. 1 plus 2 plus 1 over 1 plus 1. This is equal to 2. I did not have an indeterminate form. Since I don't have an indeterminate form, I don't need to try any algebraic simplification. You can say this can be written as x plus 1 squared limit of x plus 1 squared over x plus 1 as x approaches to 1, cancel the one of the x plus 1s, and this is still equal to 2. But since this is not indeterminate, you can just plug it in again and get the answer. Limit of 3x squared minus x minus 10, blah, blah, blah. Let's try to see if we can plug it in. 3 multiplied with 4, 12 minus 2, 10 minus 10, 0. 4 plus 10, 14 minus 14, 0 over 0. We have to think something else. Instead of 3x squared minus x minus 10, I can write 3x, x, 5, and minus 2. So instead of 3x squared minus x minus 10, I will write 3x plus 5 multiplied with x minus 2. And instead of x squared plus 5x minus 14, I will write x minus 2, 7. I will write x minus 2 multiplied with x plus 7. Limit of 3x plus 5 multiplied with x minus 2 over x minus 2 multiplied with x plus 7 as x approaches to 2, clearly canceling out the x minus 2's. Plug it in, 6 plus 5, 11. This is over. 2 plus 7, 9. Our second strategy, when the limit we are trying to find contains sum or difference of fractions, we can try to combine denominators. For example, limit of 1 over 4x minus 8 minus 1 over x squared minus 4. If you try to plug the 2, you will see 1 divided by 0, 1 divided by 0. You cannot work with it. We have to think another method. Our strategy 2 is telling us there's a difference or sum of the fractions, write them in common denominator. So instead of 4x minus 8, I can write 4 multiplied with x minus 2. This is equal to x minus 2 multiplied with x plus 2. If I expand this side with 4 and if I expand this side with x plus 2, everything works fine. I can combine the denominators. So x plus 2 minus 4 over 4 multiplied with x minus 2 multiplied with x plus 2. My numerator is equal to x minus 2 because 2 minus 4 is minus 2, negative 2. Cancel the x minus 2's, plug the 2 in, 4 multiplied with 4, 16, 1 over 16. Again, I am seeing 1 over 0, which is something I don't want to use, right? Because I cannot work with the limit properties. Two fractions again, difference of them. I will think of combining them. X plus 5. If I expand this fraction with x plus 5, I can write them with common denominator because approaching the 0. X plus 5 minus 5 over x multiplied with x plus 5 as x approaches 0. This part is 0. Cancel the x's out. Plug in the 0. 1 over 5. Our last strategy, if the limit we are working with includes roots, we can try to rationalize that root. For example, limit of root 1 plus x minus 1 over x as x approaches 0. If you try to plug in 0 over 0 form again, so this limit includes roots. Then we have to rationalize it. How do we rationalize this? By multiplying it with the reverse sign of it. But I have to multiply denominator as well, so I don't change the fraction. The logic behind this is again using a squared minus b squared can be written as a minus b multiplied with a plus b. Again, we are using this. X approaches 0. My numerator will be 1 plus x minus 1 over root 1 plus x plus 1. 0 from here. This is multiplied with x, of course. Let's write it clearly from the beginning. 1 plus x minus 1 over x multiplied with root 1 plus x plus 1. These ones cancel each other. You can simplify the x's and plug the 0 in. 1 over 0 plus 1, 0, 2. Limit of root x minus 2 over x minus 4 as x approaches to 4. Again, 0 over 0 form. I am seeing roots. I want to rationalize those roots. How can I do that? Root x minus 2 over x minus 4. Expand this, multiply this with the reverse sign of it. Root x plus 2 over root x plus 2. Which will give me x minus 4 for the numerator. I'm not going to multiply denominator because I want to simplify x minus 4's. Multiply it with root x plus 2. I can cancel these two terms. From here now, I can simply plug the value in. 1 over 4. Limit of 1 minus sine x over cosine x as x approaches to pi over 2. A trigonometric limit. Really nice. Let's see what happens if I use the properties. Sine pi over 2 is equal to 1. Cosine pi over 2 is equal to 0. So 1 minus 1 over 0, again, 0 over 0. You might say, we did not learn a strategy for this, but if you are with a trigonometric limit, you have two options. First option is using the trigonometric limits that we already know. We have another video for that. Or you can use one of these strategies if you can. When you look at this limit, you need to realize there's 1 minus sine x. And if you multiply this fraction with 1 plus sine x over 1 plus sine x, something really nice will happen. X approach to pi over 2. Again, a minus b multiplied with a plus b. Difference of squares, so therefore 1 minus sine squared x over cosine x multiplied with 1 plus sine x. I still have work to do. What is it? 1 minus sine squared x is equal to cosine squared x. Limit of cosine squared x over cosine x multiplied with 1 plus sine x as x approach to pi over 2. I can simplify one of the cosine x's here. Limit of cosine x over 1 plus sine x as x approach to pi over 2. The reason we did this is cosine x at pi over 2 is 0. So this cosine x is making my denominator 0. I need to save myself from that. And clearly I did that. Cosine x cosine x at pi over 2 is 0. 1 plus sine x as x approach to pi over 2, plug the pi over 2. 1 plus 1, which is 2, and 0 divided with 2 is 0.